Good afternoon. Good afternoon. First of all, thank you. I'd like to thank people who are in person or remotely listening to this presentation. And of course, I'd like to thank the organization of LACNIC for giving me the space to share this presentation with you. I'm Alejandro de Gidio, and we're going to make this presentation on one of the ways of optimizing traffic, considering one of the features that 464X lacked has. So this will allow us to understand how many of the limitations work, and as a suggestion, as a proposal, we'll see how we could improve that performance. A brief overview of the presentation. Maybe this might not be so popular. We'll be first speaking about the overall features of this transition mechanism, which is 464X LAT. Different patterns or traffic schemes that a service provider could have, depending on the implementation stage of IPv4 and IPv6 in their networks. Then what issues might arise once an internet service provider wishes to implement 464 in view of all the benefits offered, and then a new proposal that we're going to present, trying to avoid these issues or complications that might lead us to ruling out this implementation. Now, the overall review of 464X LAT. This is a transition mechanism to IPv6. You have several mechanisms. You have some of the category IPv6 only, which means that all the internet provisioning towards the subscribers no longer delivers IPv4, so the entire access networks through to the subscriber, only IPv6 addressing is provided. Originally, this mechanism was designed for mobile networks. Later on, they tried to figure out a way of how this could be implemented in fixed networks. One of the features is that this is a translation mechanism. Many of the service providers, because of the problems of the depletion of IPv4, end up implementing the necessary evil of CGNAT. And many of the CGNAT solutions also additionally support this translation function that is NAT64. One of the key points for the implementation of 464X LAT is the support of a functionality that we'll be seeing in a while called CLAT, which basically is a NAT46, but it has to be embedded in the CPEs. So in many cases, this is a major limitation when an internet service provider wishes to implement this. Now, what are the benefits of implementing 464X LAT? What am I aiming at? It might bring about benefits as having a lower administrative burden in terms of resources, in terms of licenses, because I no longer have to do provisioning of IPv4 addressing, only IPv6 addressing. So this would lower the burden in terms of licensing of DHCP, in terms of leases and storage of all the leases, in assigning and maintaining all the scopes of IPv4. And of course, it simplifies the setup of the access and provisioning. This is a general layout from right to left. In mobile devices, in the solution there, they sought to offer this solution. So IPv4 was not going to be assigned to the mobile device. There are applications and there are services that do require to continue working in IPv4. So the design implies including a software module that will, on one hand, do the self-provisioning of IPv4 addresses internally in the phone for those applications or services, and then this would be translated to an IPv6 when they wish to exit, because they only have IPv6 addresses assigned to that device. That NAT46 is called CLAT, Consumer Side Translator. And as part of the definition of the protocol, it implies that everything that is translated from private IPv4 to this IPv6 address has as a destination, originally it was an IPv4, probably a public one. The temporary destination would now be an IPv6 within an addressing that is in the interface inside, we can call it private, of that NAT64, which is in the provider's infrastructure called BLAT. Once the traffic reaches there, it is translated from IPv6 to an IPv4, a public IPv4, and once it reaches the final destination that the application of the mobile phone wanted. So in the fixed networks, the same scheme is applied. The difference is that we cannot apply this software module in every single subscriber device. So we have an intermediate situation, which is the CPE. This is an intermediate solution. In the CPE, we seek to continue providing private IPv4 in the network, as we currently have in all the subscribers in the CPEs, but instead of coming from a translation that normally has a NAT from a private to a public NAT, this now goes to an IPv6 of a global scope that this CPE has. So once again, based on the definition of the protocol, this implies that everything that is translated there goes with a destination IPv6 that corresponds to the inside interface of the PLAT. So this implementation once again forces the fact that all the traffic produced by the private IPv4 to IPv6 then has to go with destination to the NAT64 solution. So a summary, these two essential components are PLAT, NAT64, defined in RFC 6146. There is a translation many to one from IPv6 to IPv4 and vice versa, maintaining the session's status. This PLAT requires that this interface is all translated in a prefix that can embed these destination addresses. There are two types of prefixes that are used. The well-known prefix, which by definition is considered in the 64FF9B:/96 addressing. That's a definition. Quite obviously, because this is an addressing that has a local scope, it's not public somehow, or it's not global, then all providers can use this. But because this is private and because this is unique and I cannot reuse it in the same network, if I do so, I would have to have routing schemes that don't overlap, or at least not shared. This is limited to that only. But there is no issue with scalability. The other option is another definition of prefix for this interface, which is called network specific prefix, NSP. Instead of being an addressing that is defined in a reserved space, this NSP allows me to have any addressing that I manage as a provider. So my block has been delegated by LACNIC. I can use a portion /96, for example, that is dedicated to this function. And let me explain in a while why we could use one or the other. This is a public definition. We could even have multiple clusters of PLAT, each of these with a network-specific prefix due to load balancing or redundance or whatever reason. On the other hand, we have the customer-side translator. This is an essential component. NAT64 stateless does not maintain a table because the V4 to V6 translation is deterministic if I wish to receive traffic. As we were saying, this is a deterministic one-to-one translation. Each private IPv4 corresponds to a given IPv6, and the algorithm shows me how I have to translate that. So to summarize this, if any of you wishes to play around with this, there are multiple implementations. There are very many NAT64 implementations. These are just a few. A10, F5, Cisco, Juniper, Huawei, Joule, and others. You can use these to do your own experimentation. Some even have carrier-grade NAT solutions that support these functions. And the major challenge is to provide support to CLAT or NAT4.6 support. In the CPEs, you can download and test this with the source code you have in the GitHub for Linux and for OpenWRT. There are some vendors that even used these codes to make the version compatible with their devices. We have this basis, which is 464xLAT. Now, let us look at some of the traffic patterns that are implemented in the different cases. Many operators are doing IPv4 routing with carrier-grade NAT. This is normally because, in general, this is motivated by the exhaustion of IPv4. This is the necessary evil that we need to maintain. This has a feature that we end up having traffic with a double NAT44. This is also known as NAT444. Why is a double NAT? Well, this is because we normally have a NAT44 in the CPE, which we provision to our subscribers of a private IPv4 in the subscriber's address to a private IPv4 as well, but belongs to the provider's infrastructure, so that this finally can reach the carrier-grade NAT, which is translated to the public IPv4 and can access content in the internet. Now, this implementation, although it has a benefit of allowing me to reuse addresses for multiple subscribers, it also has some limitations which also restrict the possibility of external connections, for example, to other devices in the home of our subscribers. So depending on the implementation of the technology and how this has been configured, you might come across a situation with a decrease in the performance as a result of the translation. Let us compare this against the traffic profile that we have in the routing scheme for 464xLAT. This is similar. We have two NAT points. Instead of being double NAT44, what we have is in the CLAT a NAT46, and then the other NAT, which is the other one, the opposite one, which is NAT64, in the PLAT that we have in the infrastructure of the service provider. Quite obviously, here, although we have a double NAT, we have the benefit that we no longer have to do provisioning with IPv4 in the access network. We will have all the benefits and all the simplicity this implies. But we still have two translation points. Now, what are the issues we have? What are the problems we have? A problem arises from one of the benefits that we found as service providers all along these years. This is the implementation of certain bypass schemes, avoiding sending IPv4 traffic through the carrier-grade NAT platforms. Now, once you implement carrier-grade NAT for all the internal devices, this forces me that all the traffic coming from the internet forces all the traffic to go through the carrier-grade NAT. So what we seek to achieve through this bypass is that for the CDNs, which are the major traffic providers because of the popular content they have, so playing around with the public and private routing tables, and each provider does this in the way they can implement this, we managed to make the traffic from a public CDN server to integrate traffic to a private network. This is because it is in our network. We have no problems with the internet. Nothing prevents us from combining the public and the private routing tables.
Pusimos también un posible punto de falla. La mayoría actualmente de las CDNs públicas conocidas lo soportan, pero hay que ver cada caso particular. En cambio, si implementamos 464 XLAT, por cómo funciona, que dijimos que está forzado a todo el tráfico que se genera o va hacia una dirección privada detrás de un CPE, tiene que pasar por el PELAT. Entonces, ¿qué hacemos? Perdemos este beneficio que habíamos logrado, principalmente con los grandes tráficos de contenido, lo perdemos, porque así está definido en el protocolo. Simplemente para no demorarme más, esto es una muestra de un laboratorio donde funciona perfectamente 464 XLAT. El único, ahí debajo, lo que se puede ver es la tabla de estados de las sesiones que tiene justamente un PELAT. Esto es en un ambiente de laboratorio, ¿no? Como resumen, si los ISPs lograron este beneficio de ahorrarse, primero, costos enormes en infraestructura de CGNAT, al implementar 464 perderíamos todo eso, generando también riesgos en el servicio. Hacía un tiempo con Jordi, acá presente, habíamos trabajado en unas propuestas en el IETF para generar una mejora sobre esto, pero bueno, no hubo consenso porque implicaba en esta propuesta que habíamos hecho, implicaba realizar cambios en el firmware y bueno.
Changes in the feedback, and there was not much support of the community. We proposed more specific routers, or working with more specificity of the prefixes, or as we tend to say, what we are aiming at is to optimize traffic to avoid NAT64 for the contents in dual stack. And what is the challenge? It needs to be profitable, efficient. We shouldn't have to change protocols. It should be user-friendly, implementing it easily, good and cheap and pretty. So that leads us to routing for specificity of the prefix. RFC 6052 refers the algorithms for defining translations. It speaks of the well-known prefix and the network-specific prefix. The important thing is that for the network-specific prefix, although the well-known prefix is defined as a /96, network-specific prefix would allow us to use different lengths of prefix. For this practical case, we are using /96 compatible with the well-known prefix. The well-known prefix translates traffic from CPE to an address contained in the /96 that is configured in the inside interface of NAT64. So any public content will be embedded in that address that ends with 4A under MPLS. If I translate that to the equivalent, the algorithm would tell me that it's translating that IP on top 181.44.74.74. That's how the algorithm defines it, the translation algorithm. Now, if you know that, you could define that server actually would have an IPv6, as it's usually in dual stack, instead of assigning any global reach. I can assign an address that is embedded within the 64 of the well-known prefix, but as a /30. And here I'm using the most basic definition of routing, that is looking for the most efficient traffic for prefix specificity, so that when the CLAT traffic comes and I have to define the router in the middle, whether it goes to the PLAT or directly to the server, as it sees prefix 96 and /30 will win, and the traffic will go directly. So without modifying the protocol, the traffic can go directly. Now, this is a summary about this and what are the characteristics that finally we managed to find a way that the traffic, without altering anything, will be more efficient. The problem is that the well-known prefix is not routable through the internet. So these servers would be unable to have this addressing because they need IPv6 routing to be filled or to be controlled. So what is the other choice that has a better scope? Working with a network-specific prefix, as it is in the pool assigned by LACNIC to the ISP. It can be a public addressing. The proposal is for it to be a /96, and now I no longer have that limitation that it's not accessible. I have the benefit of being able to make the routing more efficient for prefix specificity, but it can be internet reachable. The only challenge here, just 1 minute, that in order to be able to implement this, we require collaboration of the owners of these servers, usually CDN providers, and when we install them, they may work jointly so that the IPv6 address assigned to each server may also correspond to the IPv4 address that server has been assigned. So that collaboration is easier in some cases, and in others it's more difficult because of the way each architecture works. So finally, and in closing, it's always possible to look. We always try to find more ways of implementing 464X. This doesn't solve everything, because I was discussing this with Georgie. This improves the scope, the reachability, but we depend on the owner of the technology, and would depend on the case that the client may have not changed the SDNs because sometimes the CDN providers assign depending on the resolution of the DNS. If they're using the United States DNS, they are only going to use a server in the United States, so the content goes through CLAT because it comes from the internet and not the internal network. This is all. Sorry for having taken longer time. But if you have any questions, I'll be very happy to answer them. We have a few minutes for questions, if you have any questions, or via Zoom. Hello? Hello, Norberto? Oh, no, I'm Douglas. I have a question that I repeated to LACNIC. When we speak of 464X LAT, we speak of the good things. Now, when we speak of massive networks that we depend on the feedworks and the ONTs, it's a black box. So what can you say about that? Well, I come essentially from the cable networks, HFC. The company I work with has been working with FTTH for several years. I understand that the medium or small ISPs sometimes have the ISPs with no support, or because of lack of volume of the CPEs and purchase, the provider is not willing to offer you firmware with these functionalities. However, I think that it is a joint work. At the LACNIC in 2019, we'd been working for a year, Sachem.com. We presented the first cable modem with support, 464 support, but it was a hard work. And Sagicom, this from France, started including in all their CPE lines, FTTH or the other, they included this feature of XLAT for 464. Brazil being so huge and with your huge volumes, we could have a very good opportunity for requesting providers to offer this but it depends on having the operators demand it. Yes, this is a problem because we have scenarios of firmwares that are developed specifically for certain companies for the same machines, but the other buyers don't have access to these firmwares. So that's a big problem. Yes, it's difficult. You need to insist, keep insisting. Not just you, the rest of the operators, we should set a basis stating that certain features are necessary to improve connectivity, but we should all get involved on an equal basis. Thank you. Norberto Farias, IXP Venezuela. Thank you. I have two questions, or merging it into two, but with two parts. The first, we understand that protocol may help the ISPs with not too many IPv4 number resources and avoid the DNS. Now, if I'm a small ISP and I don't have a /24, but I have a small segment, and I'm starting with that. How can I, as a small ISP, connect, for instance, to an IXP and start receiving services? I won't be able. And the other thing is, if you receive that CDN and you're speaking on IPv4, IPv6 concordance, then maybe you can negotiate that with the CDN because it's yours. But when you go to the third, an IXP, you're going to have a problem. Sure. Now, you can't, right? That's the ugly part of this. And how can the IXP help you do that? In this case, this kind of clients. No, there, what you could do, the thing is that the IXPs, as we understand it, they don't have their own addressing, or it's very limited. No, I don't mean the segment of IXPs. We are speaking of small or micro ISPs that they'll have to go and lease to enjoy that service. Yes, in those cases of smaller infrastructures, unfortunately you can't do it because you have to route traffic outside your domain. And outside your domain, you wouldn't be able to manage these solutions. No, we are right. Yes, I understand that all the users are not 100% IPv6 and the content is not 100% IPv6. So we could dispatch IPv6, but IPv4 will remain there in the air. Yes, it's limited. The possibility is limited. Yes, now I see the possibility for implementing it quite limited. As we should study the details. Thank you. There's time for one more question. Jordi Palet. And Douglas, there's an RFC 8585. It was published about 4 to 5 years ago, and it obliges the support, not just XLAT, but other. The thing is that when we buy CPEs, we need to request compliance of the IXPs, and there's a huge market of CPE vendors, and we are not restricted. I've deployed about 50 464 XLAT in many places around the world, and I haven't run into any problems finding a CPE. And sometimes I can solve it. Yes, that's a real case. What Jordi is saying is right. I'll answer this. We ran out of time. Thank you, Jordi, for your contribution. We have 1 minute. That is true. Now, I discuss it with other colleagues in the region, and maybe the situation, the reality is different here. And it's the access. There are many operators that have no support, unfortunately, of the CPEs, so they don't have access. Although maybe the hardware theoretically supported, they don't have access to that firmware, or they work with very small volumes and the provider doesn't give them any customized firmware. They give them some generic things. So it will all depend on what's happening. And other times they buy second-hand CPEs that take very big providers, and they end up sending it second-hand to other smaller providers, and they give basic internet service, but they don't have access to this. And I agree that we should insist, and there are many alternatives, but it all depends on whether you can negotiate, whether you can bargain. Of course, we would expect each internet provider to do a good job, but sometimes you can't bargain. Well, Alejandro's talk is over. Thank you all.